Can you even fathom the true scale of the universe? We're about to embark on a quest to find the ultimate cosmic frontier, the single most distant observable object. What does it tell us about the early universe, and how did its light manage to traverse billions of light years to finally reach our telescopes today? So we asked the question, can you even fathom the true scale of the universe? And your answer was yes, because you are incredible. But now you need to do it again, because we're about to embark on a quest to find the single most distant observable object. What does it tell us about the early universe, and how did its light manage to traverse billions of light years to finally reach our telescopes today? We chase the farthest light, searching for the faintest glimmer from the dawn of time. For just over a decade, astronomers have known what the most distant galaxy in the observable universe is. It was a relatively small galaxy called GNZ11. Discovered in 2012 using the Keck Observatory in Hawaii, GNZ11 existed a mere 480 million years after the Big Bang. At that time, the universe was only 770 million light years across. So while its light took around 13 billion years to reach us, the distance it traveled was much less than the almost 47 billion light years we see between us and the galaxy today. Since then, we've managed to peer even farther into the past. So what is the most distant thing we can see right now? This supermassive galaxy has been dubbed JADES GS Z14-0, and it was officially confirmed as the most distant galaxy observable by humans in mid-2025. It comes from an epoch of the universe when the first stars were shining, but those stars had yet to illuminate their surroundings enough to make the universe transparent. The James Webb Space Telescope captured this image of JADES GS Z14-0 in July 2023 as part of one of its guaranteed early release science programs. These programs were designed to show off Webb's amazing powers to the scientific community and the public alike. And this image certainly did that. Before Webb's, finding such a distant galaxy would have been impossible. And even then, it would have been hard to study. Why is that? Well, the answer lies in the fact that we're not actually looking back in time literally, but rather we're seeing back in time. You know how when you see lightning during a thunderstorm, you don't immediately know that something happened, but a few seconds later, you hear thunder. The same is true for light. It takes time to travel, and that time is different for objects close to us and those far away. Since light from distant sources takes so long to reach us, we see them as they were long ago. With each passing day, we're looking deeper and deeper into the history of the universe. When we see JADES GS Z14-0, we're seeing it as it was just 260 million years after the Big Bang. That's a mere 1% of the time that has passed since then. It's as if we're observing the universe as it was, just 2 weeks after its birth. This makes studying such old light incredibly valuable. It provides a window into a period of cosmic history that we know virtually nothing about. There's also the issue of redshift. As the universe expands, space itself stretches. In other words, all the galaxies out there are moving away from us at different speeds. Those farther away are receding faster. This means that light from distant galaxies gets stretched until it falls into the red part of the spectrum. The more distant a galaxy is, the faster it's receding and the greater its redshift. Astronomers use redshift to measure extreme distances and age. By measuring the wavelength shift, they can calculate how fast the galaxy is moving away from us, and then work out how far away it is. Redshift is denoted by the letter Z, and the higher the number, the farther away the object is. For example, GNZ11 has a redshift of 11.09, while JADES GS Z14-0 has a redshift of 17.02. To put this into context, every time we double the redshift, the distance increases by an order of magnitude. So JADES GS Z14-0 is roughly 10 times farther away than GNZ11. This also means that the light from JADES GS Z14-0 is more stretched than the light from GNZ11. As a result, the light is now outside the visible spectrum and into the infrared, which is why Webb's is needed to observe it. Jade's GS Z14-0 is incredibly bright for how far away it is, making it easier to spot than many of its high redshift counterparts. Thanks to Webb's, this galaxy's brightness allowed scientists to determine its redshift without taking spectra of the light. Spectra are extremely useful for determining redshifts, but they aren't always necessary. If the galaxy is bright enough, astronomers can estimate its redshift by comparing its brightness with models of galaxies at various distances. After confirming the redshift with Webb's near-infrared camera NIRCam, the team was able to analyze the galaxy in more detail. JD's GS Z14-0 was captured by Webb's in two different near-infrared filters. The shorter wavelength filter captures light that has been stretched slightly. Meanwhile, the longer wavelength filter reveals light that has been stretched more. The difference between the two images results in a beautiful contrasting effect that makes Jade's GS Z14-0 pop out of the background. Jade's GS Z14-0 is what astronomers call a bright red and near-infrared galaxy. This means that while it's invisible to our eyes, it glows brightly at longer infrared wavelengths. It also means that the galaxy isn't really red. That color was imposed by astronomers to help visualize the data. In reality, Jade's GS Z14-0 would appear black to our eyes because its light is too far into the infrared for us to see. We currently believe that galaxies like Jade's GS Z14-0 represent a sort of transition in the history of our universe. They existed before the cosmic fog cleared and the universe became transparent. In other words, before the universe became neutral. Before this happened, the universe was opaque, and the first stars had only just begun to illuminate their surroundings. During this period, photons from the first luminous objects bounced around the universe, unable to travel more than a few million light years before being absorbed by a cloud of hydrogen. Once the clouds were ionized, meaning their electrons were stripped away, the photons were able to roam freely throughout the universe. However, Jade's GS Z14-0's light was emitted at a time when the universe was still neutral and opaque. Its light was trapped in the neutral hydrogen fog and couldn't get very far. JD's GS Z14-0 itself, meanwhile, was one of the first galaxies to emerge from the fog. It was shining brightly just a few 100 million years after the Big Bang. But how exactly did it shine so brightly? As you may have noticed, Jade's GS Z14-0 looks a lot like modern galaxies, despite existing in the early stages of cosmic history. It's large, containing hundreds of billions of stars, and it has a similar structure to galaxies we see today. In fact, JD's GS Z14-0 is larger than expected for a galaxy of its age. Scientists are puzzled by how it grew so large so soon after the Big Bang, especially considering it's 10 times more massive than many of its peers. One explanation is that this giant was once smaller, but encountered another galaxy that was even bigger. The two crashed into each other and merged, forming the large galaxy we see today. But this scenario is unlikely as such encounters are rare, at least in modern times. Another possibility is that this ancient galaxy grew rapidly due to the presence of dark matter. Dark matter is a mysterious substance that makes up a quarter of the mass in the universe. It doesn't interact with baryonic matter, which is the stuff that makes up stars, planets, and people. But dark matter does interact gravitationally. Therefore, it can play a role in the formation of galaxies. According to some theories, dark matter halos surrounding galaxies acted as seeds for the first galaxies, causing them to grow much faster than they would have otherwise. More research will be needed to figure out whether or not this is true. But one thing's for sure, Jade's GS Z14-0 and galaxies like it were able to start shining so brightly so soon after the Big Bang because they contained a lot of gas and dust. This material would eventually form new stars, allowing the galaxies to illuminate their surroundings and ionize the neutral hydrogen fog. But what caused these ancient galaxies to shine so brightly in the first place? This is unknown. but astronomers think they may have been fueled by supermassive black holes. At the center of most galaxies, like Jade's GS Z14, lies a supermassive black hole surrounded by a glowing disk of hot gas. Every now and then, the black hole consumes material from its surroundings and grows in size. In some cases, this happens at an astonishing rate. Scientists think these hungry black holes powered the brightest galaxies in the early universe, allowing them to shine so brightly they punched through the fog and ionized their surroundings. However, this process must have ended relatively quickly. Just a few 100 million years after the Big Bang, the universe was already mostly transparent. So whatever fuel was powering these galaxies must have run out pretty soon. It's important to note that Jade's GS Z14 is the most distant galaxy we can see, but it's not the most distant galaxy in the universe. There's a limit to how far we can see, which is known as the cosmic horizon. This is the boundary of the observable universe, and it prevents us from seeing infinitely far into space. Even the most powerful telescopes in the world can't see beyond the cosmic horizon. That's because light takes time to travel, and there's only so much time available. Since the Big Bang, the universe has expanded dramatically, stretching the fabric of space. As a result, we can only see back to a certain point in time. In other words, we can only see so far. The light from objects beyond this distance hasn't had enough time to reach us yet. As of now, the cosmic horizon sits about 47 billion light-years away. This means that anything farther away is currently outside our view. However, as technology advances, our ability to see farther into space will improve. Eventually, we may be able to see even farther back in time and witness the universe as it was in its earliest days. The James Webb Space Telescope is just getting started, so keep an eye out for updates from this remarkable telescope. You never know what discoveries it'll make next. Thanks for watching this episode. If you want to learn more about the wonders of space, hit that like and subscribe button down below. As always, see you next time, and keep looking up.